Hello out there on this beautiful day. So what are you going to look at today is revision on probability, okay? And most we'll be doing is solving problems, okay? So what I would like you to do while out there is to try and do some of the problem with us, okay? Try and really persist, okay? So we'll start with the first question. Let's look at what the question looked like, okay? And I'll encourage you at home there to what? Read the question, okay? Let's see what do you need to solve some of the problems we're going to do with us, okay? So before we do that, who uses probability as part of their job? Have you ever thought about that? Do we really have people that use probability? Yes, quite a lot, okay? And data analysts, which is a new career which is growing, they use data. Insurance company do use data. I think each and every career, especially in the future, one will require the use of data to do some statistics or probability, okay? So many careers will use data, but we have lots and lots of careers that use data, because if you do have data, you can calculate some kind of probability, okay? So let's look at what we have on some of the keywords. What is a sample space? A sample space, if I have a die, okay, my sample space will be 1, 2, 3, 4, 5, 6. Okay, if a die has 1 to 6, if I have a fair coin, my sample space will be head or tail, because if I flip a coin, I'll get head or tail. Then what about independent event? Are we together? Are we together? Independent event, if the likelihood of event A, if I have two events, A and B, the likelihood of A happens is not affected by the B happening. Are we together? If I flip a coin, me getting tail doesn't mean it will affect head for the next flip. Not really. Not. Okay. Dependent event really depends on the other. Independent and dependent events. So that is independent. You can see from the word independent. It's not, it's independent, and dependent can be affected by the other. Okay. So independent event and dependent event, I mean, you can think about from being independent and from being dependent. And let's look at some more keywords. Complementary event, and we're going to look at mutually exclusive event. And we'll really define this later, because we're going to look at the summary. Complementary, I'll think of this as complementary. If the probability that it will rain today is 30%, what is a complementary of that? It will be 70%, because the two add up to 1. That will be the complementary. So the probability it will rain is 30%, and the complementary of that will be not raining. Are we all together? That's the complementary of that. And mutually exclusive, they can't happen at the same time. Those are the mutually exclusive event, and we'll look at that when we look at our summary. Clearly, what does mutually exclusive look like? Okay. And this is mutually inclusive, which happens mutually exclusive. They don't happen at the same time. Inclusive can happen same time. Okay. So let's look at this, our summary. If you have two events, inclusive A and B, then we know that this is an inclusive. The probability of A or B is the same as probability of A plus the probability of B minus the probability of A and B. And this is the same as that. Okay. So inclusive, okay, meaning there's some intersection between the two cycles. So you have event A and event B. Inclusive, there's some intersection between the two events. Okay. So the probability of A plus the probability of B minus the intersection, which is this part. But for mutually exclusive, so mutually exclusive event. So mutually exclusive means the two events can happen at the same time. So you have a circle there, event there, and the intersection between the two events is actually 0. There's nothing common between the two events altogether. So how will this change? It will actually make this part 0. Are we together? It will make the probability of A and B occurring will be 0. Okay? So it means the probability of A or B is the same as probability of A plus the probability of B. Are we together? This is the same means as the intersection. And this is the same as OR. Are we together? But we'll definitely use the OR like that. Okay? This is another notation. Fantastic. So we spoke about complementary when we started as our keywords. So complementary events are two mutually exclusive events that together contain all the outcomes in the sample space. Are we together? For two complementary events, so we say, this is the probability not A. If I put something like that there, that means not A. And the probability of not A is 1 minus the probability of A. The same example as rain and not raining. Okay? 1 would be like the 100% minus the 30%. If the probability it will rain is 30%, what is the probability it won't rain? 100% minus 30, which is 70%. Okay. Are we together? So now, which is the same as this, probability of A is also 1 minus the probability of not A. Are we all together? Now let's talk about statistical independent. So to test where the two events A and B are independent, we have to check whether the probability of A and B is the same as the probability of A multiplied by the probability of B. So if you take the probability of A times the probability of B, and we find it's the same as the intersection, it implies the two events are statistically independent. Okay, hope this makes sense. So let's look at an example. So this is what is given. The probability of not A and not B is 0.1. The probability of A is 0.5. The probability of B is 0.75. The question is, find the probability of A and B. So firstly, what does this mean? The probability of A and not B is the unshaded region in the Venn diagram, because with event A and event B is the outside. That's meaning, which is 0.1. Are we all together? Makes sense? Okay. Now, we know that we can do this and say now, probability of A or B, are we all together? It's 1 minus what? 0.1. Are we together? Because the sample space, everything in the sample space adds up to 1. Are we together? If outside is 0.1, then the inside is what? It's 0.9. Okay. Then what we can do, we can use this formula. This formula will be given to you, that the probability of A or B is the same as probability of A, probability of B, minus the intersection. Are we all together? Then what we can do, we can put everything together. We know that the probability of B is, A or B is 0.9. Are we together? The probability of A, it's given there, which is 0.45. The probability of B, 0.75. And we have calculated, and what are we looking for? That's what are we looking for? The probability of A and B, which is the intersection there. So let's put everything together. So this is 0.9. Are we together? and we put our 0.45 there, 0.75, and what are we calculating, which is the intersection, and we just solve this equation, okay? So what do I mean? I have to bring everything the other side, okay, because we're solving that, and if you solve this, I've added this 2, I get 0.12, 0.2, and if we solve further, we get that probability of A and B is 0.3. Are we together? So what was important with this question was we knew that this is 0.1 outside. Then we knew that this whole thing will be 0.9. That was the key part, because we know that this whole thing will add up to 1. That was the key part. And knowing that this is 0.9, then what we could do is to use the formula, which is given to us to calculate the intersection. Are we all together? And we're given 2 more information. Great. Fantastic. Okay, so we'll come back and we'll try some of the problems after the break, and hope you're ready there with your pen and paper.